get to do another visual aid today. So if I drop a watermelon or a football off top of my house, what happens?
It falls.
It falls. Why? Gravity. So we're going to talk about gravity for a little bit. Home dude Galileo performed a whole bunch of experiments trying to figure out why objects fall, how fast they fall, even when they're pushed or they're thrown, they all wind up going the same speed, because science. And they fall at relatively the same speed of 32 feet per second squared, meaning the distance, the amount of change moved by gravity is basically this. This is not something we need to like memorize or anything, but like we're going to use it today. So we're going to look at this guy. So suppose I'm on a roof. I mean, my table's not tall enough, but I want to be on a roof. Oh, my football's wearing it out. Too bad. And I'm going to drop a watermelon. So I'm going to take a watermelon, boop, drop it. I want you to figure out how far the watermelon has fallen in these times. So we're going to use this equation and these decimals all the way over. I want you to evaluate it. So what are we going to do with these values? Plug them in, substitute them in. Okay? I did clean up all the calculators. You can grab the calculators, they're in the bed. Like, you can use the calculators, it's fine. I just cleaned them up because I was trying to make my room tidy. It looked like a bomb went off in here. It was a little chaotic. And if you want to use a dry erase board, I got dry erase boards and markers and erasers up here. If you want to do it on scratch paper, that's fine. A few of you have access to dry erase boards on the table, mostly because I only had one roll of it, and I'm still letting the rest of it unwrinkle. Okay, so plug them in. Boop. Thank you, Grant. Awesome. So plug in these values, because we're going to talk about them. I'm going to move you guys' beautiful catapult pictures. I mean, I have berets. You even do that. Oh yeah, you're one of the few people that actually have access to a dry erase board on the desk.
Definitely saw that.
That is the one thing I miss about my old desks, is that they were dry erasable. But the tables make it so much easier for the projects in here. Doing the card sort things on those slanty desks was not it.
I was not this time for your bed. When I was a little kid, when I was over with yeah, but not for that part.
Here.
For that part, you literally
Okay.
to see where oh, so that this is the one. I'm moving the cookie right now.
I'm a fighter. I don't know. I would bring it just in case. I don't know that it's gonna take that long, but if it does take that long, you don't wanna have to like run back here. That's Here we go. Sneaky way.
And then you'd also have to grab this one is hard.
On this same drive?
Yeah.
Yeah, you do substitute.
Mm-hmm. This one fix this side for my.
No, I think I could beat you.
I am so good at art.
I think I could beat you in the drawing contest.
I'm pretty sure, like, if you have a little sibling, they could beat me in a drawing contest.
I was just gonna say the same thing. If I know a little kid, I'll sign your drawing.
Oh, yeah, no, I'm trying
You see the
to.
first one? That was like an action drawing.
That, to be fair, that one's supposed to.
Are you through?
Yes.
See?
That's what we're gonna talk about next.
I think you're like that and you don't even know it.
I was gonna say, I'm very good at clear drawings. They're not very pretty. I mean, do you remember my dolphin, Fabian?
Your dolphin?
The dolphin?
And then she turns it off.
We'll get to talk about the dolphin, but my dolphin is beautiful. Okay, I guess we're doing a brown dolphin.
Several screenshots on my phone because she ain't know how to turn it on.
Dolphin. If you feeling extra fancy, give it a bottle nose.
Yes.
I don't judge your art.
No, that's one thing I really appreciate you though. 'Cause I feel like you're the type of teacher like no matter how it gets done, it's like it's not judged. Like
As long as it gets done in a way that works and we didn't make mistakes that cancel each other out, I don't care how your brain flows. Just get it to flow.
effort is effort.
All right. So let's start. Oop, that's not what I meant. Let's start talking through this. So if we're on the ground or on the roof 60 feet above. So here I am. I'm standing on my roof and I'm holding a watermelon. Looks just like me. How far has the watermelon traveled in 0.25 seconds? How far did it move?
I keep on getting negative numbers. That's right.
No, you're 100%. Because did my watermelon go up or did it go down?
It went down.
It went down. So how far did it go?
-1.
So it went down, just like, whoop, just a little bit. Down 1. So that's after a quarter second. When we got to half a second, how far down did it go? Down 4. How about when we got to 3/4 of a second? Down 9. Keep going. 16. 25. 36. I'm way too close. 49.
60.
Oh, I didn't see that.
2 and 2.5. Hit those ones up. Negative 64. And then 81. That's my question. Which ones of these don't make sense?
Negative 64. And
Why?
because they're below the ground.
They're below the ground. I'm only 60 feet up. So what happens between 1.75 and 2?
It stops.
Hits the ground. Splork. Watermelon explosion. Oh, let me see, do I have a red? So there are some things that limit our constraints on these quadratics. Because that's what this is. This is a quadratic. It's an x squared. So it hits the ground right here and we get watermelon sploosh. And you know, I am fine artiste. Sploosh. Okay? So we're going to work with equations. We're still going to have, when we have story problems, we're going to have times when we have to logic our way through. And say, we have to stop here because that's where the ground is. So we're going to look at another piece here. So now I'm going to go to space. And I'm, let's say, on the moon. And I'm going to drop my marker. Gravity does not hold there. So boop, 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 boop. I'm going to be 15 feet. That 100% looks like that character is doing something they should not when I use the brown marker. So we'll go here. There we go. We are 15 feet off of whatever surface here. Okay, so if spaceship me throws a ball at 5 feet per second, we're wanting to figure out what's going to happen as time goes on and how is it different than the gravity situation. So see if we can figure out what's going to happen with no gravity, so we're in space. What happens to the ball? So think about it for a second. So my minus 16x squared equation is not in play here. So we're going to make kind of a similar list. I want you to get and see how high this ball is off the ground up to 100 seconds. And there's a couple of different ways to think about it.
Wait.
Low key up.
How far is our ball going to be after 100 seconds? See if we can figure that out. There's no gravity, so we're not using the x squared. And there's a couple of different ways you can approach it. Huh?
This is what I'm thinking. So let's say you got what? Each number going away from 0 to 100 to this.
I mean, do you have to do every single one?
From 0 to. I have to go by. No, you
It's
know.
good now.
You're right.
So do I put the number?
Yeah? Yeah, you absolutely can. object for us. So, how do you hold it? So we have a graph and cost of days. You're doing great. You have an equation and let's do the cost of days. That's the same thing. It's your equation. It uses cost of days. So we've got cost, we've got days. How are you gonna graph it? So how do we graph it? Uh-huh. 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 So that is a way to do it, where you're substituting a value like that. This is our days. This is how many days it is. That's the x. So you can absolutely do that where you plug one in, you points to get out your mouth. That's absolutely a valid way to approach it. You can also do that as a slope and do an mx plus b situation. It's
I just was looking at the rate dash. Like, how would I calculate this?
okay, so we're gonna talk about that in 2 minutes, because we're still doing this one.
Oh.
We're still doing this. We're still doing this. We'll talk about around it here a little bit. We're almost done. We're almost through it.
You look like you was finna give us an essence.
It's not. I keep not here for a couple days was okay. What's that? All right. So what do we think about our space ball? In space, no gravity. What's happening? Couple of different ways you can think about this. How far did the ball go after 100 seconds?
I said 500 feet up.
Yep. Definitely one way to think about it is we launch up. Is anything stopping it? No, we got no gravity. This thing keep going. I had to go find my Earth Day. I'm only so tall. All right, so yeah, that's definitely one way to think about it. Hitting this button so that we don't lose the recording. Other way to think about it, because we didn't tell you. Maybe one that way. And it's going to stay 15 feet off the ground. So it could be that it's just still 15 feet off the ground. It wasn't clear. The wording was ambiguous. So it just said the location. Maybe they meant height. Maybe they meant height. Maybe they meant distance. But this distance is going to be the same as the launch height. So it would have been 500 feet that way. Or 500 feet that way. I mean, or that way. Direction doesn't matter in space. Okay? So what the difference is this one was a linear. We went 5x. Most of us dealt with 5x or 5x plus 15. If it went straight up. This is starting to deal with our quadratics where it went a different amount each time. Each of these gaps got bigger. This went by 5, 5, 5, 5, 5, 5, 5, 5, 5. So our change was by 5. It was a constant rate of change. And this is not constant. That's really what we're looking at here, is it changes by different amounts each time versus changing by the same amount each time. Okay, so our last piece for today is actually going to be on the computer. It's on Canvas. So you're going to go to today's page or straight to the the T6H2 assignment. And we're going to talk through this a little bit. It does use a page in your workbook. We're going to start comparing equations and noticing pieces on here. So this is also like a homework assignment. So we're going to work with this. So when you go to the Canvas page, here, you can go to the current chapter. Oh, it takes us to, I gotta update that link, so it takes us to Unit 6. You're gonna wanna go to Unit 6. You can either go straight here to 229, or you can go to 6H2. Either way, in here it also has a link. Gravity, just there. Always has a relevant meme. We talked about gravity, so we have a gravity meme. Ha 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 ha. Click on this big link that says in-class activity. When you scroll down to the bottom, it's got a link that says period 7. If you click on that, it'll take you to the Desmos page. You do not have to sign in. You can if you want to. You do have a login with your Google, or you can continue not signing in. Just put your people name. I guess it doesn't have to be your whole people name, but a people name. Not your 500 number. I don't know those. So, but also don't put like P-Dog or whatever. Because I won't know who that is either. So people name. It doesn't have to be your Skyward name, your government name, anything like that. Something I know relative to you. And what we're going to do is we're going to talk through some stuff. So the first page is kind of a paragraph.
I like the lyrics now.
Really, you're going to want to go to the second page. And it's going to have something that looks like this. It says, what's the difference between the red and the blue graphs? And this is in your workbooks. It says page 69 and 70, but I don't think that's right. It's page 68. Yeah, page 68 in your book. And what we're doing is we're looking at these equations, like straight up, not looking at the graph, just looking at the equations, and saying, what's the difference between this equation and that equation? What is the difference between r of x and b of x? Like the physical equations. It's, yeah, there's a minus sign, right? That's literally the only difference. And I know it's super tiny here. Desmos is a little bit of a jerk on letting me customize stuff. So the only difference here is that this guy's negative. Oh, it's going to show the typing stuff. As soon as you type stuff in, it is going to pop up. Hi. I like your smiley face. Just because this is the teacher page. All right, I'll switch it so that we do a put y'all on blast page. I'm just going to put me, because that's me, and I'm running it. Boop. Okay, so we're looking at the difference in the equations, that one's negative. And then we're also going to look at the pictures and notice what happened there. What's different? I'm going to move this trippy. Canvas page, big link.
Parabolas.
Parabolas, technically correct, not detailed. The difference between them.
Red and blue. That was fine.
One's red, one's blue. Not wrong, but what's the difference between red and blue?
One of them's positive, one of them's negative.
Mm-hmm.
And
What does that do to the graph?
one of them shift right and shift vertically. And one of them is like compressed.
It is not compressed. That is not the math word we're looking for.
Huh?
Start with an R.
Start with R.
Just because you're trying to find that word, even though you just need to sit down and get in a Canvas page because everybody else typing in here.
What's the second letter?
E.
What was it, reversed?
Not gonna say reversed. Reflected. I would also take upside down. It's also upside
Did
down.
you already tell them?
No, she didn't.
No, I didn't, but that's okay. You could also just sit down and get out of the way. Because you're standing up right in front of everybody. Okay, so we're looking at these equations and looking at the pictures. So we're trying to find the difference between the two equations, what piece in the equation has changed, and what piece on the picture has changed. So this is a link on the Desmos page, which is also homework 2 for this chapter. So this is part of a homework assignment. Okay? And it's going to give us a few different options on here. You don't have to be super detailed about what you say. So the difference between the red and blue graphs, we might put in, I have to use the keyboard. One's upside down. We might notice that. Because the only thing that changed in my equations down here is I have a negative number in front.
Oh, is this the ABC?
Uh-huh. So we're sharing that. And then one's negative, one's upside down, one's positive, one's negative, one's reversed. I love it. I love the comments. Awesome, guys. So then you can go on to the next one. Up here is where we have the next button, top right. And we have another equation. It's very similar. What's the difference between the red and green graphs? And I know one's narrower. Then remember the math word when they get really narrow like that? I'm not saying you have to, like, just do we remember?
Let me start with.
We say when it gets really tall and skinny, we take our graph and it goes, this is wicked yoga.
Can you tell me what it starts with?
S. Stretches? It stretches. Yeah. I'm not saying we have to remember those words. We're going to go through all those words when we need to. This is, again, still very beginning of this chapter. Just seeing what pieces we remember. Noticing that it goes narrower. Notice that it's skinnier. Notice that it's taller, even though the graph ends in the same dang place. But my y-intercept is still the same. What is different on the equations?
3, the 8.
The 3, that A, the number in front, that starting place, the first thing we see, whatever way you word it. But we're noticing the difference in these equations. What we're going to do as you go through this is it's going to change different little pieces. And we're trying to figure out maybe what patterns we see here. And we'll talk through these more tomorrow when we start working with the 3 equations and the 3 different kinds of equations and the 3 different forms of equations. We're going to remember the 3 different kinds of quadratic equations that we have. But this is starting with trying to notice the patterns here. What does that A change, that number in front? What does the C change, the guy on the end? We're going to notice a little bit about B, but B's weird. And that's okay. Okay? So you're going to work through this. This is going to be homework 2, and all of, like, you don't have to save when you get to the end. You don't have to upload anything to Canvas. I will automatically be able to pull it up. Okay, but that's what you're going to work through. All right, so this is what we are going to do for the rest of the period. You guys have the rest of the time to work on this. You can ask questions. I know some of us have questions on the project. Now is an excellent time to do that too, but you guys have the rest of the time to work on stuff. So you don't have to do it as homework. You can do it now. You're just going through these, and it's all the same thing. Compare the 2 graphs, figure out what's different, figure out what changed. Okay, so you're trying to notice patterns. But that is all you need to do, and that's going to be homework 2. Okay? So, I'm going to put up the thing. I also want to point out, because this is the only class I haven't actually had anybody do it with, sound problem? This is extra credit. I post a new one like every week. And I brought it up like a month ago, but I don't have nobody's done it. And this one actually has real cookies. Challenge problem's over there. If you submit it today or tomorrow, you get a cookie, like an actual physical cookie. Okay, so but you guys get the rest of the time to work on this. Let me know if you have questions about this or about the project or whatever.